So in this video, I'm going to be talking about incrementality testing. I've talked about this in the past in my previous videos, but in this particular video, I'm going to be talking about the types of incrementality testing and why they're not really created equal. So I'm actually looking at Google's very recent document that it has brought out in the middle of 2024. This is known as the Modern Measurement Playbook. And in this document, they have actually very nicely laid out the different kinds of experimentation approaches that different brands can take in order to understand how profitable their different marketing initiatives are. So obviously, it covers marketing mix modeling, it covers attribution modeling, but it also goes on to talk about incrementality testing. Because as you must be aware, if you're watching this video, and if you're not, then you should know that incrementality testing is one of the most established methods, the most scientific methods of proving causality. Okay, so suppose you're running ads on Google and Facebook, and you want to establish if running ads on Google or a certain spend in Google actually led to an increase in revenue or in profit. If you want to prove that, then incrementality testing is required, because attribution modeling is not going to do that, and to a large extent, even advanced frameworks like MMM is not going to be able to do that. So in this document, obviously, it's a very long document, as you can see, 44-page long. But what I'm going to talk to is actually in the appendix section. What I'm going to talk about is in the appendix section, and this is within the section where it actually clarifies the differences between concepts like analysis, experiments, and incrementality. So in this particular section here, you'll see that there is this headline, which is pre-post versus optimization versus incrementality. So essentially, incrementality can be of different types, and strictly speaking, as you can see, pre-post analysis, or the analysis which Google describes as optimization approach, these are testing, of course, and they are very similar to incrementality, but they are different kinds of A/B experiments. So strictly speaking, they are not incrementality, but you can still broadly classify with them within A/B testing experiments, basically. So, but the most important point here is that not all of them are actually going to be able to establish causal impact. And ultimately, incrementality is what you want to get to in order to establish causal impact. So pre-post analysis simply means that you have a split between your control and your treatment group, and there is actually a before-after sort of a thing. So, for instance, for a time period, say in the period of March, in the month of March, you actually ran, or you did not have, or perhaps you did run Facebook ads or a particular channel, and then that was through a normal level of spending. But in the month after that, suppose you double the spend, or you sort of increase the multiply the spend by several times, several x. So that is a post or treatment period, and this pre-post analysis is what Google here is rightly describing as a sort of sequential analysis, as you can see, because there are two periods, one after the other, and there is going to be a directional analysis from it. So the interpretation is going to be in the form of directional analysis rather than true causal impact. Similarly, if you're going for an optimization sort of approach, where you split the ad between a control group and a treatment group, and the treatment group actually sees a variation of that same ad. By the way, this is happening in the simultaneous. These two are happening simultaneously, so it's not happening at two different periods, as you can understand, which was the case with pre-post analysis. So here, you're going to be able to optimize your ads, right? So you're trying to understand what variant or what iteration of the ad is going to perform better. So that's the optimization approach. Then we come to what is the true and official incrementality approach, where you actually have the split between the control and the treatment group. where the treatment group actually sees the ad and the control group does not see it at all. Not a variation of the ad, but not the ad at all. Okay, they don't see the ad at all. So this is basically, sometimes this is also referred to as the holdout testing. And I'm going to show you the examples of the first and the last approaches. So the pre-post analysis and incrementality. And in fact, I'm going to call all of these incrementality, and you'll see, by and large, people call these incrementality testing. But strictly speaking, you should know that pre-post analysis is not incrementality testing. Okay, so I'm going to jump now into a couple of templates, and I'm going to just show you from scratch, what this would typically look like. So these are the three templates that I'm going to walk through. This last one, actually, I'm going to show you right at the end. That's the one which is a true incrementality testing using the concept of holdout testing. But first, I'm going to show you through the examples of your regular pre-post analysis, which is very, very, very commonly done, and it's much simpler to execute. So this is the simplest version, by the way. As you can see here, that there are just a few columns here. First, you take the dates, different dates. Then you have the total traffic. Then you have paid traffic, organic traffic, and then you have paid share. Okay, so so as you can see here, paid share is obviously going to be the share of total, the total share of other, paid traffic share of total traffic. And then obviously you have paid, organic, and total traffic for each of these individual dates. So if we obviously sum this up, you're going to get the total traffic. So it's a very simple sort of experiment. You're just looking at the traffic metric. And as you can understand, the traffic metric is a direct function of the marketing spends as well. So if you have paid traffic, then obviously it is coming through some sort of paid marketing activity. So what is happening here is, you can see there are two periods which are marked in green and blue, but it's not just these two periods, but you will see that up to a certain point, you'll see that there was significant paid traffic, and then you start to quickly taper it off, and then you'll see, then you just turn it off, and it actually tapers off over a couple of days, and then it just goes to zero, right? So it was, as you can see here in the green graph here. So there was paid traffic with its undulations and ups and downs and fluctuations, and then it sort of started dipping, and then it just completely goes to zero, right? So you've turned off the paid traffic. So what you're trying to do here is holdout testing in a way as well, and you're trying to understand a before-after effect as well. Okay. So this is a very simple version which is trying to combine, in a sense, both holdout testing and the before-after effect. Okay. Now, what we are doing is we're going to try and understand the impact of this change. Okay, so the traffic before is basically this green period, and the traffic after is basically the traffic in this blue period. So why are we taking this green period and this blue period and leaving out a few days in between? Let me explain a very important concept here, which is slightly unrelated, but nonetheless important in this context, and that is the concept of ad stock. Okay, so ad stock is essentially a concept which means that there's always a delayed effect or a lag effect of advertising or marketing activity on your users. Okay, so if you have been running paid ads for a while and you turn it off, the effect of those paid ads aren't going to just disappear instantly. Okay, so the effect is going to wear off gradually. There's going to be a tapering off of this impact. So that is essentially the reason why we have kept a certain buffer period here to allow for that ad stock effect to actually wear off, because we want to measure the true impact of turning off paid ads, and we don't want it to be clouded. The judgment of this and the influence of this experiment to be clouded by ad stock effect as much as possible, okay, as much as practicable, because it's actually difficult. Ad stock effect often is is often an exponential sort of a function, and or could be geometric, so it just takes a while to go away entirely. But nonetheless, this is trying to sort of take into account or offset that impact of ad stock or delayed effect. And so now we have 14 days from each of these pre and post periods. Pre-period for 14 days of the pre-period where the paid ads were running, and another 14 days from the post period. And you can see that we have taken the traffic before from this period, the traffic after from this period, and we have a drop off. Okay, so 13.4% traffic drop off has happened. Total traffic, that is, has happened after we have switched off paid ads. And so this is So this then is the way you actually measure incrementality, because you're trying to understand the average. Okay, so you're trying to understand, okay, how much reported paid traffic was there. So you're saying that, okay, on an average in this period, this was your paid traffic. Okay, and on an average, this is uh, the incremental effect. Okay, which is where you're trying to just subtract the H22 and H23, as you can see here. So you're just subtracting the actual traffic differences. Okay, so the incrementality, therefore, is the reported traffic, um, or rather, it's the incremental increase of due to paid ads, and the actual um, reported paid traffic. Okay, so you can understand. So the incremental impact of paid traffic over the actual paid reported traffic is what's going to give you your incrementality. So this is one way of measuring incrementality, and you can also look at it using sum. So this was obviously using averages. Okay, so I hope this is clear, and from the graph also you can understand what is going on here. That the green graph is actually tapering down, and then you have a blue graph which is actually your organic traffic and your total traffic. So you're trying to understand if your total traffic is at all getting impacted or not. Okay, by switching off paid traffic. So this is a kind of incrementality testing, very simple format. As you can see, you're only just looking at traffic. Now I'm going to show you a more complex version of this. Okay, so this is a pre-post analysis, and you can do pre-post analysis in this way also. And this time I'm actually using much more comprehensive data, and I'm using data from Shopify. Okay, so from Shopify I've got gross sales, orders, new customer gross sales, new customer orders, returning customer gross sales, returning customer orders, Facebook spend, Google spend. Okay, so I'm just dumping the data from Shopify for these columns, from gross sales to OC orders, and obviously I've put in Facebook and Google spends. So what has happened here is, if I just jump into this particular part, is that we are doing a variable testing on Facebook ad spend, which is, so our variable here is Facebook ad spend, and it could have been other channels ad spend as well. We are just considering two channels here, and we are looking at what is the impact of the delta or the change in Facebook ad spend from the control period to the test period. So at the start of the video I gave an example. So this was the example I was actually referring to, that you might have a pre-period of, say, the month of March, and you have a post-period of the month of April. And we ran Facebook ads normally during the month of March, but during April, we just gave it a much bigger boost by 137%. Okay, so that delta percentage of Facebook ad spend must have had some impact. So we're trying to understand that incremental impact on what outcome variable. In our case, it's the gross sales. Okay, so what's the delta gross sales? It actually is negative, as you can see here. So obviously, Facebook did not do a very good job. The increase in spend did not really yield positive results. It wasn't a great decision, but nonetheless, it was worth the test, right? You're trying to scale. You sometimes have to do such tests. But there are actually other ways to, to actually figure out if it's going to be worth the test or not. But we're going to deal with that in some other videos at a later date. So this is the delta number of new customer orders. This is another important thing as well, and you can see that's also negative. It's important because from Facebook, channels like Facebook, you probably try to do more acquisition, so that later down the line they can actually, generate more lifetime revenue for you, because of because of repeat purchases. All right, so that's essentially the idea. So now I'm looking at the control period and test period differences between, for the different metrics, the gross orders and gross sales, and new customer orders, and returning customer gross sales. So all of the metrics that I just showed here a while back in the raw data sheet. And then we are just calculating the differential, which is just the differences and the percentage differences on the baseline period. So as you can see, the differential is 0.01, negative 0.01% for gross sales. Okay, so that's what we already saw before, and we have negative for orders and gross sales and new customer gross sales, new customer orders. It's only the returning customer orders and gross sales that have actually given some positive returns. Okay, but honestly, this is what you should be looking at: the new customer and obviously the gross sales, gross numbers as well. So clearly, this wasn't a good idea. But if you have to actually statistically prove that there is causality you actually have to do statistical testing for that, and for that you have to find out things like the regression slope and the F statistic and p-value, and then you can look at the incremental ROI percentage. Okay, so the p-value here, if our alpha, for instance, if for 95% confidence interval, our p-value would be 0.05, and therefore, as you can see here, it's much more than that, right? Almost you know it's 10 times more than that, right? So it's 0.6, right? And the correlation coefficient is also very low, um, and it's it varies between 0 and it varies. It can go up to 1, but as you can see here, it varies between -1 and 1, but it's much lesser than 1, as you can see. So it's a very weak correlation that we have tried to measure. So the correlation, by the way, has been measured between gross sales as the outcome variable and as the input variable. We have taken Facebook spend. So these are obviously the coefficients of the regression that we did. So apart from correlation, we also did regression analysis, and from that we also came up with p-value. Okay, and like I said, so this is the p-value, and we also had the standard deviation values here. But standard deviation is really an intermediate sort of metric. So this is just giving you the spread of each of these variables. Okay, so it's not particularly crucial for your interpretation, but this is a value that you have to nonetheless arrive at in order to get some other values. Okay. So there's actually there's a lot going on behind the scenes for this particular template. This is actually deriving value from the output of what is called the linest formula, which is actually doing the regression analysis. But yeah, I'm not going into that. So it's actually doing some other calculations as well. It actually manually calculated p-value from the t-statistic value, and which in itself also used the values of the slope and the standard error of the slope. But let's not get into those statistics. I'm just pointing out those aspects of the statistical concepts which are absolutely crucial in order to understand this particular template. If you want to understand it deeper, do get in touch with me. I can definitely arrange for some sort of special discussion. But for the moment, this is how you can do incrementality testing. But like I said, this is primarily a pre-post analysis testing. So perhaps not strictly speaking incrementality testing, but you're still doing it in a more scientific manner. And obviously, depending on your data set, you'll see that you'll have a decent p-value and perhaps your incremental ROI, which is basically saying that, okay, what percentage of returns will I get for every dollar that I spend? Okay, so for every $100, you're only going to get like 0.08, okay, return. So if it were 100%, then you would know that, okay, I'm getting exact. That's like break even. That's I'm getting back exactly what I spent. So it's 0.08. So you can understand how extremely unprofitable this particular exercise has been, because the gross sales has nowhere near increased as much as you have really increased the spend on Facebook. The R-squared value is again a very important metric which gives you the explainability of the variance in the outcome variable by the input variable. Okay, so again, it has to be as close to 1 in order for the model to be good, but it's very low, as you can see, 0.004, 0.005 or thereabout. So this is another model. Okay, so this is another template rather, and this also follows the pre-post analysis. So going back to that document that we were looking at, so we saw a couple of templates now with pre-post analysis. One of them, the first one, which was the relatively easier version, actually had that element of holdout testing in it as well, as you can see, because it did stop paid ads completely, right? But now what we're going to look at is an absolutely full-fledged method of doing holdout testing, and can be probably called the most scientific and the more established version of fully fleshed out version of incrementality testing. So what we are doing here is we obviously have a test period, and we are looking at two particular metrics here. So which is the cost per add to cart and the cost per sales. Okay, you can easily look at only one metric. If purchase or the sales is your ultimate KPI that you're concerned about, then just look at that metric. Okay, in this case, it has two. It's looking at two metrics in just order to understand how it is affecting key metrics along the funnel. So we are actually doing this for several segments. As you can see, again, in your case, the segments can vary, okay, easily. So in my case, it was for a personal brand a personal care brand rather, and basically into hair care and healthy hair and stuff like that. So obviously the relevant segments in our case, in this particular case, would be females, and we have a fixed age range, as you can see, which is under 30, and then we had different so the variation happened in terms of gender, the variation happened in terms of age, not in terms of age, but in terms of in terms of age as well. So under 30 and over 30, and also the interests. So they could have been interested in visiting spas. They might have been interested in they might have been shampoo users. So sports lovers or movie geeks. So different kinds of segments that I've tested collectively. And the objective here was to understand how many, how much of a particular channel spend is going to be, and in this case it's Facebook. How much of an impact it would have on cost per add to cart and cost per sales. Okay, so you can say on add to cart and sales therefore. So the way it has been done is, like I said, through holdout testing, and we have this concept where we always try to have an equal proportion of holdout and test subjects. And this is basically related to the concept of sample ratio mismatch. So SRM is a very important concept, because if you have SRM, or a sample ratio mismatch, between your test and your control and test groups, then your analysis is going to be flawed. Okay, and sometimes it does happen. That's why you need advanced statistical software to actually control this all the time. But that can happen, and this is a very good example we have in this very template, actually showcasing that sort of a thing. So the audience reach is basically the actual number of people that this particular campaign has been able to reach. Okay, so the test audience has actually reached 37,982 in this case, and all the other numbers, as you can see, in the respective cases. But we're going to be discussing the segment one, so that it's going to be easier to follow. The same principle and logic is going to be is going to be followed for the other segments as well. So by the way, so we are basically doing holdout testing, individual incremental tests for each of these segments separately. Okay, so essentially there are 8 incremental tests going on in this template. I will actually make a future version of this, and I'll share with you. You can do it on your own as well. A much more simpler version of it, which will only have one incrementality test for one campaign. Okay, and then you can obviously use that use that particular template in order to extrapolate for more segments. But nonetheless, let us look at segment 1 for now. And as you can see, the reach here is actually less than the test prospects. So that was obviously our initial target number of people that we wanted to reach, and we obviously wanted to have the same number in the holdout. And the holdout, by the way, is simply the control group, and the test group is the treatment group. So we had an equal number theoretically, but eventually we ended up reaching a lesser number, which is expected, right? And then the test audience match rate is simply that proportion of people we actually reached in comparison to the out of the total theoretical test prospects number. And then we have the test spend. This is manually inputted. These values are all manually inputted. And similarly, how many tests add to cart for this particular campaign when you are actually having that test campaign. And holdout, as you can understand, that they are not being shown the ad. And for them, how many add to cart happen for the test audience, how many sales happen for the test audience, and similarly for holdout, how many add to cart, additions to cart, how many sales happen. And then we have some ratios here. Okay, so how do we measure the add to cart rate? So we obviously take the add to cart divided by the audience. Okay, so we have a couple of different ways, as you can see here, and that is because of this particular reach factor. So in one case we are just dividing by the campaign reach, and in another case we are just taking the entire test prospects number, okay, irrespective of the actual reach. And similarly, we have the number for close rate. So close rate is simply sales by the total prospects. So we have 10% or 10.87% conversion rate, you can say, and that add to cart rate is 1.912%. So as you can see, these are all marked in orangish sort of color, and that's because these are the ones we are really going to consider. And similarly, we have the holdout add to cart rate, the holdout close rate, which is simply sales or sales conversion rate, and then we have the lift. Okay, so the lift is the value, the metric, which is going to give you the the measure of incrementality. Okay, the actual incremental impact, and this, by the way, can be a causal impact because we have all the things built in, as long as we can establish statistical significance. So that's going to happen a little bit later. Okay, but let's just quickly go through this bit first. So add to cart rate lift is simply there are quite a few formulas here. I've actually written down a couple of these formulas, and I've also broken them down for you. Okay, so for instance, if we let's just skip this and directly jump into the incremental CPA, and that probably is going to be taking care of everything. So if we look at incremental CPA, it's simply being calculated like this. Okay, I'm not obviously explaining each cell references. You can look them up, pause the video and look them up as well if you want. But simply what we're doing here is we are doing a spend by test ADC minus the total audience into the ADC rate. Okay, that's obvious. So that's how we are doing the test incremental CPA. And similarly, we are doing the CPS. In that case, we simply multiply the second part by the conversion rate as well. Okay. So that's how we get the incremental value. So we have the base values now. This is what we are looking at. What is the incremental CPA and the incremental CPS? But have we established causality? For that, we have to do statistical significance testing. Okay, and we are going to use a few formula for that. So we're going to use the formula of standard error. We're going to use the formula of standard error of difference. So this, by the way, is the conversion rate. But this could be anything. In our case, it would be the standard error of the proportion. So in our case, the proportion here is going to be just a second. Yeah, so in our case, it's going to be add to cart, and it will be the add to cart rate basically. Okay, so the test error rate, as you can see here, yeah, right. So we are looking at add to cart, for instance, and we are basically doing a standard error of that calculation. So standard error is basically that particular proportion divided by the total audience and the square root of that. Okay, so that is how it's calculated. Again, in a different video, I might explain each of this formula, but you can just look at this formula and try to understand what's going on here. And similarly, we do it for the test error rate, and just like we do for holdout error rate, again, for each of the segments, we calculate something called the Z-score, which is basically the difference of the two values. So the difference of so this is the difference of the add to cart rates for the test and the holdout samples and populations, and then you just divide it by the standard error difference. Okay, so standard error of difference, by the way, is basically each of the standard errors sum together, and then you have the square root of that. So that's the definition of standard error of difference. So these formulas are actually going on behind the scenes. Okay, and if you just look at them, you will understand that this is what is going on. Okay, so this is as you can see here. So power C23 2 simply means that it's the square of this particular value. Okay, C23 is this value here. So you're just taking the square of these two, summing them up, and then taking the square root over them, just and dividing the difference of the two values, the add to cart values. That's how we're establishing add to cart. So this, by the way, is happening for add to cart. You can also do this statistical test of significance for sales as well, right? So I'll leave that as a homework for you guys. You can do that on your own. But then you actually calculate standard deviation, and standard deviation is calculated simply by the formula that Z-score is X minus mu by sigma. Sigma is standard deviation, so you just do a transposition and you get a sigma value from there. You already have Z-score, and you obviously have X and mu being your holdout and test values. And p-value is given by this formula. Don't try to go into that, but this is just Google Sheets formula. But p-value is essentially 1 minus your statistical significance, and statistical significance. Your confidence interval, and your statistical significance level is basically going to be calculated by this particular formula here. So norm.s.bist, and you just take the Z-score value of that, and it's going to give you the p-value. Okay, so the p-value is the value at which you can which you can really say whether or not the null hypothesis is going to be rejected. Okay, and the null hypothesis in this case is going to be that there is no incremental impact, or there is no statistically significant impact of Facebook ad spend on your sales, or in this case on additions to cart. So if that value is below a certain alpha value, then it's statistically significant. And as you can see, those alpha values are determined by these levels here. So if we have 90% confidence interval, which means that it's there is a doubt of 10%. So that means you will take the alpha value as 0.1. So as you can see here in this formula, you're trying to check if the p-value is less than 0.1. Okay, so it's statistically significant at this level of confidence. It is statistically significant at 95 level of confidence, which is going to be 0.05 alpha value, and 99% as well, which is going to be 0.01. So as you can see here in many of these segments, the incrementality testing is actually saying that the Facebook ad spend is having an incremental impact on on your outcome metrics, which is additions to cart in this case, and you have to do similar testing for statistical significance testing for sales as well, which is cost per sales or simply sales. So this is basically what I wanted to discuss. This is incrementality testing for you. I've discussed the different ways of looking at incrementality testing, which are similar to A/B testing, but have different methodologies. So pre-post analysis, I've explained through a couple of examples, and this is an example which does not rely just on pre-post analysis alone, and it actually goes on deep into holdout testing, and through statistical significance testing, it establishes causality. So I hope this was useful to you guys. Do reach out to me if you have any questions, if you need any kind of custom solutions. I'm always happy to provide those. And thanks for watching, and do like, share, and subscribe, and help spread the word about my work. Thank you.